Alright, hello. My name is Matthew. I am going to be talking to you about Newton's laws of motions. I am doing this for a science project we have to do. And so today I'm going to be explaining those, talking about those with fruits, vegetables, whatever you want to call them. So I'm going to be explaining that with food. It'll be interesting to keep you interested, and I'm going to help you understand it more. So let's get started. Just going to start it off right here. Newton's first law. Newton's first law of motion, called the law of inertia. What Newton is saying is an object at rest remains at rest, and an object in motion maintains its velocity unless it experiences an unbalanced force. Let me explain what this is. An object at rest, man, it'll remain there at rest unless it experiences an unbalanced force. Bam! That's its unbalanced force. It doesn't remain at rest anymore. Alright, now we're talking about an object in motion. If this was, going same speed, never stopped, an object in motion, it'll maintain its velocity, alright? It'll maintain going this way unless it experiences an unbalanced force. Bam! See, this thing comes, bam! It's this orange unbalanced force. Oh no. It's not going to maintain its velocity anymore. What he's saying is this will keep going unless it experiences unbalanced force agreements at all. Alright, another way of let me explain this is this orange sitting here, alright? This orange is going to be moving, okay? This one will keep going, experiences this, oh no, bam, it falls down. Too bad. That was explaining a little bit of Newton's first law of motion. I hope you understand that. Another example is a windmill. A windmill, spins and spins and spins. It'll keep doing that. It'll keep spinning and spinning unless something interferes with it. A plane crashes into it, and another windmill can't move. The plane's stuck in there. Technically, it would blow up, but we're not going to get technical here, even though we kind of are. Anyways, let me not get stalled. It's like the 47th time I try to do this video. Newton's second law, law of force. This is what Newton said. The unbalanced force acting on an object equals the object's mass times its acceleration. Now, I know a lot of people right now watching this just made no sense to me. Alright. Let me take an example. Let's say a crane. It is lifting up something, okay? What this is asking is alright, Newton's second law of motion, law of force. This is what Newton says. He says, the unbalanced force acting on an object equals the object's mass times its acceleration. This isn't going to really make a lot of sense. Let me explain this to you. This lemon is a lemon. Alright, let's say this is a 5-pound lemon. Really heavy. Who cares? Okay, it's a 5-pound lemon. I am picking up this lemon, alright? And I'm moving it, let's say 10 miles an hour, alright? Now, what would this unbalanced force require to accelerate this lemon? So how much force is required for me to accelerate this lemon upward? To find this out, what you have to do is multiply the weight of this lemon and how fast it's moving and find out how much force I would need to pull it up. See what I mean? That explains his second law. A free fall, I'm going to help you out with this, is when an object, Alright, Newton's third law, action/reaction law. This is what it says. It says, for every action force, there is an equal and opposite reaction force. Alright, forces always occur in pairs. Alright, the action and reaction forces act of different objects at the same time. Alright, let me explain this. This lemon, sitting here, alright, this lemon. on top of here, alright? This is pushing. This lemon, what this is saying is, let's say this action force is this lemon pushing down on this orange. That is the action force pushing down on this orange, alright? There is an equal and opposite reaction force. The orange is also pushing up on the lemon at the same time. Now, that's what they mean by an equal. They're equal, both doing their part, and they both have a reaction force. Alright, this is pushing down the orange. It has a reaction. It's pushing back up on this. This is pushing up on this. This is reacting to this. That's what he means. An example of this could be me jumping on a trampoline. I have an action force pushing down the trampoline, and the trampoline also has a reaction force pushing up back against me. That's what Newton's third law explains. I hope that helped you out understand a little better. If not, I could care less. This is just for a science video. Also, some terms you're going to need to know to understand Newton's laws of motion are: net force is the combination of all the forces acting on an object. All the forces means number one, where it says, it'll maintain its velocity. This is going to sit here until I start pushing on against it. That's number one. Also, while I'm doing that, Newton's second law is occurring where it's having a reaction, Newton's third law is occurring when it's having a reaction, and then also Newton's second law is also happening here, where you need to know the amount of force being pushed upon this object, multiply the mass and the acceleration, and that's what net force is. You're going to need to know inertia. Inertia is the tendency of an object to remain at rest or in motion with a constant velocity. This thing, okay, let's start out with the rest. That's inertia. It's staying there. It's not moving. Now, if this was to keep going like that, it didn't stop moving, kept going, that would also be inertia. It's remaining at a constant velocity. It's remaining in motion. Alright, that's what inertia is. Simple to understand. Yeah, that's what inertia is. You're going to need to know what motion is. Motion is any object that is changing its position. Look, my hand's standing, so bam, that's motion. Look, this orange is standing there, bam, that's motion. Look, I'm standing still, bam, that's motion. Look, this is motion right here. I'm moving back and forth, motion. You're also going to need to know acceleration. Acceleration is you're going to need to know velocity. Velocity is the same as speed, except that it includes direction. So this would be the same as speed, but it's going a certain way. See, this is velocity. Direction can be described. You can describe the direction. I mean, like north, south. At an angle. Positive, negative, and a line of motion. You're gonna need to know what momentum is. Momentum is a calculation of a mass traveling at a certain velocity. So momentum. This is mass traveling at a certain velocity. Momentum is a calculation of the mass traveling at a certain velocity. So it's just, like an estimate, kind of, That's what it is, an estimate. Balanced forces. Balanced forces are forces that are acting on an object that combine to equal a net force of 0. So balanced forces acting on an object. This is object. Balanced force, they're both acting on this object that combine a net force of 0. So this in here, that'd be like these two are forces, but bam, they have equal. They're equal net forces, and look, 0. Net force 0. Bam, 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 bam. If they were the same, create zero. That's what a balanced force is. It's balanced. Bam, look, balance. Unbalanced forces are forces that combine to produce a net force not equal to zero. This forces that combine to produce a net force. So that means this hits this, this hits this. That's not a balanced force. Look, bam, bam. Look, that wasn't a balanced force. Bam, that's a balanced force. That's a balanced forces. You know, you learn that again. Bam, bam, unbalanced force. Understand that? Good. Friction. Friction is force between two objects in contact that opposes the motion of either object. So, force between two objects in contact that opposes the motion of either object. See this? These two rubbing against each other. This is friction. Alright? It smells like lemon. It smells good. These oranges. Friction. Friction. This is friction. The force caused by friction depends on the type of texture of the surface involved. This, different kind of force friction. This, different time of friction. This, different time of friction. That's what friction is. So, the force caused by friction, it just depends on the type, you know. This is going to be a different force. This is going to be a different force. So friction is. Applied force. This is the force applied to an object. Look, this is what an applied force is, the force applied to an object. Air resistance is the type of frictional force that acts upon object traveling through the air. This is moving, right? Air resistance is the type of force that acts upon the object traveling through the air. This would be air resistance. It's moving here. This scrapes across the air resistance. Another thing is it's just moving, the air pushing against it. That's air resistance. That explains. Gravity. Gravity is the force caused by the attraction of gravity between two objects. So this and this table. Gravity is the force that is pulling this orange down to hit the table. Look, gravity just occurred right there. Bam, gravity occurred again. That's gravity. Weight is the effect of Earth's gravity on an object toward the Earth's core. So this has weight. Weight is like, it's the effect. Earth's gravity has an effect on this object. Depending on the object, it's going to have a different weight because of gravity. Normal force is the force perpendicular to the surface in contact with the object. This is the table. Normal force is this force hitting that. You know, it is the perpendicular force in contact with the object. You know, it's going to be like over here and stuff. So that explains that in a sense. Alright, thank you for watching this video. I think I explained everything that's in the paper that I needed to explain. Hopefully it helped you understand Newton's laws of motion.